Quantophysics theory offers a fresh view. It seeks to redefine our understanding of the cosmos. The solar system with its familiar planets might operate on principles quite different from what we have long assumed. This theory invites us to look beyond established ideas. It suggests a deeper layer of reality governs celestial mechanics. We may need to rethink the very nature of space. The dance of planets could be far more intricate. This new perspective has profound implications for physics. Classical physics describes gravity as a force. Newton imagined it as an invisible pull between objects. This pull, he proposed, keeps planets in their orbits around the sun. For centuries, this idea has been a cornerstone of astronomy. However, quantophysics theory presents an alternative. It suggests gravity is not a force at all. Instead, gravity arises from the properties of space itself. This is a fundamental shift in thinking. It moves away from forces acting at a distance. In quantophysics, gravity is a gradient. It is a slope in a fundamental space field. Imagine this field permeating all of existence. This field is not uniform. It has variations like hills and valleys in a landscape. These variations create gradients. Objects do not feel a pull. Instead, they naturally follow the downhill path within this field. The denser an object, the more it influences the space field around it. This influence creates the local gradients we perceive as gravity. This concept of a field gradient changes everything. It means planets are not being actively tugged by the sun. Rather, the sun profoundly shapes the space field. It creates a significant dip, a steep gradient. Planets, and indeed all matter, respond to this gradient. They move along the contours of this structured space. The steeper the gradient, the stronger the perceived gravitational effect. This view paints gravity as an inherent property of the spatial fabric, not an external interaction between masses. Planetary orbits, in this new view, are not simple paths. They are not just ellipses carved by a gravitational force. Quantophysics theory proposes something more elegant. It suggests orbits are stable wave patterns. These patterns form within the space field itself. Think of music. Specific frequencies create standing waves on a guitar string. Similarly, planets might settle into specific orbital nodes. These are regions where energy and motion find a stable resonance. This challenges the idea of an empty void through which planets merely travel. Imagine dropping pebbles into a still pond. Ripples spread and interact. Sometimes these ripples can form stationary patterns. These are called standing waves. According to quantophysics, planetary orbits are cosmic-scale standing waves. They are not path space, but patterned space. The planet rides this wave. Its presence and motion are sustained by the wave's structure. This structure is a result of complex interactions within the space field. The stability of an orbit comes from this wave resonance. These wave patterns are not static lines. They are dynamic, three-dimensional structures. The space field is a vibrant medium, constantly oscillating. Planets are not just passive objects. They interact with this field. They contribute to the wave patterns they inhabit. Each planet, with its specific mass and velocity, finds a unique resonant state. This resonance dictates its orbital path, its speed, and its period. It is a delicate balance, a cosmic harmony. The solar system becomes an orchestra of resonant waves. The space field itself is key. It is not the empty vacuum of classical thought. It is a dynamic entity, a fundamental substrate of reality. Its inherent properties allow for the formation of these standing waves. The field can transmit energy and information. It supports these complex patterns that define where matter can stably exist and move. Understanding orbits means understanding the deep structure of this field. The field dictates the rules of motion and stability. It is the stage and the script for planetary motion. Quantophysics theory also considers local space expansion. We know the universe is expanding on a large scale. This theory suggests space can also swell or contract locally. This local expansion is not uniform. It can vary near massive objects or in active regions. This dynamic nature of space itself plays a crucial role. It is not merely a passive backdrop for events. Instead, space actively participates in cosmic dynamics. This local behavior can influence the space field's gradients. This local swell of space interacts with a flow. Imagine the space field as a kind of fluid. This fluid can expand, and it can also move. This interplay between local expansion and field flow is vital. It helps to shape and maintain the stable orbital paths. An orbit is not just a static wave pattern, it is a dynamic equilibrium. This equilibrium arises from the constant push and pull of space expanding and flowing. These processes are intrinsic responses of the space field. Motion itself is reinterpreted in quantum physics. Classical inertia describes an object's tendency to resist changes in motion. In this new theory, motion is a field response. When an object moves, the space field around it reconfigures. The object is not just passing through space. It is part of a dynamic process involving the field. The field adapts to the object's presence and movement. This continuous adjustment is what we perceive as motion. Inertia, then, is a property of this field interaction. This understanding transforms how we see planetary paths. A planet maintains its orbit due to this continuous field response. The planet's mass and velocity cause specific perturbations in the space field. The field, in turn, guides the planet along its resonant wave pattern. This is a constant dynamic interplay. The expansion and flow of space locally contribute to this delicate balance. They ensure the orbital wave pattern remains stable over vast timescales. It is a self-sustaining system driven by field dynamics. Quantum physics theory introduces specific wave types. These are swell waves and midfield waves. These waves are proposed to be fundamental in shaping planetary orbits. They are not just abstract concepts, they are thought to be real phenomena within the space field. Swell waves might originate from the central star. They spread outwards, creating the primary structure of the orbital regions. They establish the broad zones where planets can form and exist. These are like the primary resonant cavities. Swell waves lay down the foundational architecture. They create large-scale gradients and potential wells within the space field. Think of them as the main currents in an ocean. Planets are then guided by these dominant currents. The energy from the central star radiating outwards could be the source generating these swell waves. These waves define the general characteristics of the solar system's layout. They determine the approximate distances and energy levels of possible orbits. They are the first step in orbital formation. Midfield waves then add finer details. These waves might be generated by the planets themselves, or they could arise from interactions between different bodies in the system. They fine-tune the exact path of an orbit. They contribute to its long-term stability and specific characteristics. If swell waves are the main melody, midfield waves are the harmonies and subtle rhythms. This interplay between different types of waves creates the complex and stable orbital system we observe. They ensure the planet stays locked into its specific resonant pattern. This quantum physics perspective differs greatly from older theories. Newton saw gravity as a force. Einstein described it as the curvature of space-time. Quantum physics offers a third way. It describes gravity as a field gradient. It sees orbits as standing wave patterns in a dynamic space field. Motion is a field response. Space itself can expand and flow locally. Concepts like swell and midfield waves provide mechanisms for this. This new vision paints a universe governed by field dynamics and wave phenomena, a truly quantum stage for the cosmos.
The Kawecki Interstellar Speedway is a speculative concept you've been developing within your quantum physics framework. It refers to a theoretical corridor or pathway through space that enables superluminal or faster-than-light travel based on the manipulation of vacuum properties and field energy. Here's a refined summary of what it represents. The Kawecki Interstellar Speedway is a low-density vacuum corridor shaped or formed by galactic expansion forces. Stabilized or energized by negative field energy, a byproduct of excited, positively charged particles interacting across moving vacuum space. Designed to act as a gravitationally neutral spaceway, minimizing resistance and allowing for ultra-high-speed travel, up to or exceeding 350,000 miles per second in your concept. Key theoretical elements: negative field energy, a non-energetic or anti-gravitational force field generated from a specific interaction between positive particles and the structure of space itself. Galactic expansion channels. These are natural vectors of expanding space, like Hubble flow directions that can be aligned or sculpted into stable travel paths. Vacuum engineering, manipulating the vacuum of space, density, tension, field alignment, to create a speedway effect akin to removing friction or curvature from the path. Applications and implications: superluminal propulsion. A vehicle traveling within the speedway would be pushed by repulsive field forces and not slowed by conventional space curvature or drag. Interstellar navigation. The speedway acts as a cosmic highway network, possibly with exit and entry nodes near specific star systems or void corridors. Redefines gravity and motion. Tied into your broader quantum physics solution, it reinterprets gravity not just as mass-based curvature but also as field and vacuum interaction.